The 100-meter sprint is a race run on a straight section of track. During a race, the velocity measured in meters per second of an athlete is given by this expression here, where t is the time in seconds measured from the moment the athlete starts to move from the start line. Determine the acceleration of the athlete 3 seconds after moving from the start line. So a of t is the differential of the velocity. So we're going to use the chain rule. Remember, with the exponential, the argument doesn't change, but we'll have to multiply by the negative 0.8. Negative 10 times negative 0.8 is 8. So it's going to be 8e to the negative 0.8t. Doing the same sort of thing here, we'll have the 0.2 multiplying the 0.05. And so that's going to be 0.01 e to the 0.2t. Remember, we are calculator assumed, and therefore you could have done that on the calculator. And then we just need to evaluate. So we just want a of 3. So that's going to be 8e to the negative 0.8 times 3. Take away 0.01 times e to the 0.2 times 3. And if you put that into your calculator, you'll get 0.708 meters per second squared. Using calculus, determine the maximum velocity of the athlete during the race and the time t at which it is achieved. Now, it might be worth doing this on the calculator now. So we had the original expression v. Now I might just define my function. So let's call the function, let's call it v. And the variable, let's use x rather than t. And the expression is going to be negative 10. And then we'll have e to the negative 0.8x. And take away 0.05 e to the 0.2x, and then we'll add the 10.05. So I just went back and redid that because it didn't like me using the variable v here. I had to use the v here. So it's now done. And we can differentiate that by doing, that's not that template, this one, d dx of v. He probably wants me to write v of x. And we've done that. It might be better to do it in standard. And that is equivalent to what I got before. And we can show that by dragging that to here and evaluating that with x equal to 3. And do that in decimal mode. And you can see we've got the 0.708. So that's the right expression. So we want a equal to 0 for the maximum velocity. So a equals 0. So this one here, put that equals 0, and we just put in front of there a solve, like so. And we get 6.68 seconds. Now we need to show that that is a maximum, and we actually need to find the maximum velocity. So for the maximum velocity, we want v of 6.68, and we'll use a bit more of the number. So our expression for v we already programmed in, so we can go here and just do v of that last answer, and it will calculate it for us. So 9.81 meters per second. Now we might need to show that this is in fact a maximum. So we've got a dashed, not x, but t. It's x on the calculator. So this was our expression here for the derivative. Let's just copy that. And we're going to differentiate with respect to x. I'm just going to paste that in there. And we get this. Might be best to be in standard again. So is negative e to the t plus 3,200 e to the negative 4x over 5 all over 500. But the important thing is what that evaluates to at the time we found for the maximum. So in Math 3 we use the given line, and probably just drag that answer down. This one here, including the x. Let's just copy it. And we'll drag it down here, put it there. And it would have been better in decimal. So it's negative 0.03. So a dashed of 6.68 is negative 0.03, and the negative implies it's a max. The displacement x of the athlete is 0 meters at the start of the race. Determine an expression for the displacement of the athlete during the race. Now we know that we get to displacement by integrating velocity, and the velocity was negative 10 e to the negative 0.8 t. Take away 0.05 e to the 0.2 t plus 10.05. So we need to integrate that. Once again, we could do it on the class pad, but we don't need to. So we're going to get negative 10 e to the negative 0.8 t. Remember, this time we need to divide by that negative 0.8. Take away 0.05 e to the 0.2 t. Using the reverse chain, we need to divide by the 0.2, and then we're going to have 10.05 t plus some constant. That gives me 12.5 e to the negative 0.8 t. Take away 0.25 e to the 0.2 t plus 10.05 t plus a constant. But we know that x of 0 is equal to 0. So 0 is equal to, e to the 0 is 1, so it's going to be 12.5. Take away 0.25, this bit will be 0 if t is 0, plus c, and that gives me that c is negative 12.25. So x is going to be 12.5 e to the negative 0.8 t, take away 0.25 e to the 0.2 t, plus 10.05 t take away 12.25. Determine the time t at which the athlete finishes the 100-meter race. So what we need is for x to be 100. So we want to solve 100 equals 12.5 e to the negative 0.8t. Take away 0.25 e to the 0.2t plus 10.05t minus 12.25. So we can just solve that on the calculator. It's easy enough to do. And if you do that, you'll find that t is equal to 11.41 seconds.